Alright, so I'm going to show you how to do an exponential growth problem. I think this one's actually exponential decay using calculus. So what we know about exponential functions is their derivative definition, the rate of change of y with respect to time, is k times y. So the rate of change is proportional to the amount of k that you have. We also know the solution, which is y equals some initial amount, a, times e to the kt. And we can get this by solving this differential equation, which I'll avoid here. It uses separation of variables. It's not real difficult. What we're going to do is know that this has this for a solution and use it to answer this question. So I took this out of our book, and I'm going to set it up. First thing I need to do is figure out k. So I'm going to say, all right, well, we started out with 1,000 kilograms. So it's 1,000 times e to the kt. And for exponential growth, a is the amount you start out with. Not true for logistic growth. A doesn't quite mean that. But for exponential growth, it's easy. So we started out with 1,000 times e to the kt, and we ended up with 800 after 10 hours. So really, I should have t equals 10. So let me rewrite that. 800 equals 1,000 times e to the k times 10. Okay. I'm going to solve that. Divide by 1,000 and take the natural log of both sides. So it's going to be the natural log of 0.8 equals 10 times k. So I'm skipping some steps here, but if you imagine dividing and then taking the natural log, the e is going to go away. So you get this. So then I'm just going to make the note that k equals the natural log of 0.8 divided by 10. And then I will use that in my next calculation. I don't want to round, so I'm going to leave it there. So the question says, all right, if this happens in the first 10 hours, how much is left after 14 more hours? So we're asking this question, what's left if you start out with 1,000 times e to the, now we know k, but I'm just going to leave it that way, k times t, I'm going to say t is 24. So essentially I go to my calculator and plug this in. What's 1,000 times e to the k, remember that k is this, times 24. And the answer we get is approximately 585.350 kilograms left of raw sugar.